Boys, can we do gas laws?
No, thank you, bruh. I'm perfectly well, thanks. I don't need to go.
No, Joe. Gas laws not letting it rip. It's what we use to figure out how gases behave. Look, Barack, as we make the volume of the box go down and down, the particles faster.
This is called Bose's law. If we increase one thing, the other has to go down.
Boyle's law, not Bozo's law.
Sorry, Donald, I'm not exactly Irish.
What the former president is trying to say is that pressure and volume are inversely proportional at a constant temperature.
V1 times V1 equals P2 times V2.
But what if we heat things up?
You're hopeless, Joe.
Wait, let him cook.
If we add heat to the box, the particles move faster.
Just like Hunter's lawyer fee.
Brothers place, if the particles move faster, that means that an increase in temperature also increases the pressure. Right, Donald?
Oh, that's correct. Chemists like me would call this Gay-Lussac's law, which states that temperature and pressure are directly proportional at a constant volume.
T1 over T1 equals P2 over T2.
But what if we heat the box and it expands?
So does temperature affect volume or pressure?
It depends on what's held constant, Sleepy Joe. If the pressure is held constant and temperature changes, the volume will also change. Basic chemistry.
So now, if we keep the pressure constant and increase the temperature, the volume also increases.
This is Charles' law, which states that temperature and volume are directly proportional at a constant pressure.
V1 over T1 equals V2 over T2.
But what if I want to change pressure, volume, and temperature all together?
Since we know that pressure and volume are inversely proportional, but temperature is directly proportional to both of them, we can get a new equation called the combined gas law. This only works if we have a constant number of moles.
P1 times V1 all over T1 equals P2 times V2 all over T2.
Donald, I want to change the number of moles.
Elon can help.
Hello, chat. If we want to change the number of moles, we use the ideal gas law, PV equals nRT.
What is R?
It is a constant which has a value of 0.0821 liters ATM over moles. Kelvin?
What the hell are those units?
Just relax, Donald. The trick is to match your units. If you're using R, the units of the other variables in the equation have to align with it, just like with all the other formulas.
To convert between different units, you need to know that 101.3 kilopascals is equal to 1 ATM, which is also equal to 760 millimeters mercury as a conversion.
Bruh, don't forget all the temperatures should be in Kelvin or you're going to get negative answers. Degrees Celsius plus 273.15 is the Kelvin temperature.
Another cool thing about the ideal gas law is that it can be used to derive other formulas.
We know that moles are just the mass divided by the molar mass, which gives us this new formula. Hallelujah.
And we get an even more useful formula when we substitute density for mass over volume.
There is one more important gas law we didn't talk about.
Avogadro's law. It says that any gases at the same temperature and pressure contains an equal number of particles and take equal volume.
STP is just an abbreviation for standard temperature and pressure, which is 273.15 Kelvin and 1 ATM. That's STP. Any 1 mole of gas occupies 22.4 liters.
Thank you guys. Now I'm going to ace my chemistry final exam.
Don't forget to keep track of your sig figs.